We'll begin with the amazing hip. We'll start with some of the constitutions of the bony components, that being the femur and the pelvis. The femur fits into the pelvis through a ball that fits into a socket. So the ball, or the head of the femur, will fit into the socket of the pelvis, which is the acetabulum. The acetabulum is actually composed of three different bones, the ilium, the ischium, and the pubis. But it's most important for us to understand how they're attached. Now, we don't really have to go into the capsular connection, but understanding the ligaments is going to be important for us. The three most important ligaments we need to know when it comes to the hip will be the iliofemoral, which is this Y-banded ligament crossing here. And we can't really see on this chart, but Sean has somewhere a model for us of the ischiofemoral ligament, which is a spiraling banded ligament that runs around the entire neck of the femur. This is going to be important for us because of the fact that this ischiofemoral ligament unwinds during flexion. So when your knee is flexed, when you're lifting your knee and flex the hip, this is going to unwind the pelvis. There's one other ligament that we need to address, and that is, it's going to be difficult to see in here, but this pubofemoral ligament. Together, these three ligaments form a Z, and when we understand these two, the iliofemoral and the pubofemoral, wrapped but with the ischiofemoral, we're going to understand the closed packed and loose packed positions of the hip. So, which brings us to our next point. I'm actually going to ask you to put that down. And the greatest articulation in the hip is when the hip is flexed, laterally rotated, and abducted. That's when the head of the femur is maximally congruent with the acetabulum of the pelvis. However, now you can put that down. However, this is what's interesting. This coxofemoral joint is one of the few joints where the maximum congruence is not the closed packed position for the joint. Now we see that if that's a loose packed position, we're going to be able to manipulate the joint. Now we kind of introduced this in immovable object, unstoppable force. If his knee is bent, rotated outwards, this ligament is lax. Now remember the ischiofemoral, the spiraling banding ligament, it's not taut. It's taut to the inside. It has more capsular ligamentous strength inside than it does outside. This begins to unwind it, which is why that storing of elastic energy in the ligaments easily brings him down to the ground. Okay, a little bit further is for us, I wanted to mention about, yeah, I don't actually want you to stay down there. Huh? I want you to stay down there. With the hip, I wanted to mention about the lumbar pelvic rhythm, and that is, can you lay on your side? As you lift the hip and flex it abductively, the pelvis is recruited into this motion and the lumbar. So he has less of a range of motion if the hip joint is isolated than if it's not isolated, because the pelvis is recruited into the motion and then the lumbar and the rest of the spine. So for us to abduct, we must have an isolated position on this appendage in order to control the limb more effectively. If we stay at this and we see that it unwinds during flexion, there's another interesting fact here, and that is the capsule of the hip, and we won't really be able to see. Bring this in here. The capsule of the hip is stronger anteriorly and inferiorly, meaning on the bottom and in the front. Superiorly and posteriorly, in the back and on the top, it's weak and loose. Just from its construction, it protects, the capsule protects itself better against hyperextension than it does hyperflexion, because of the whole constitution of ambulation, walking. We need that mechanical strength. Now, if his leg is bent here, we can make the rear of the joint maximally taut at a greater range of motion. Now that's beginning to affect him. At a greater range of motion than if we turn him over. Very limited range of motion, because it's more maximally taut to protect against hyperextension than hyperflexion. That means working here, we can easily, well, we can a lot more easily cause a rupture in the ligament and capsule when we do hyperflexion, I'm sorry, then whoosh, put this down, put this up, then hyperextension. This is going to be more challenging because it works against the capsular strength. Now, keep this leg here and come a little bit this way. There was one more thing I wanted to say, and that was in relation to the length tension. When it comes to the recruitment of the muscles, the optimal length tension for the muscles of the hip that are involved in the hip, and we'll be going into those in just a minute, will be in the position that he's in right now, or with both right here. This is maximal tension recruitment for the muscles surrounding and controlling and producing movement through the hip. In the next section, we're going to go specifically into which muscles and why, and how we can move around, with, or through that tension. One more point before we continue with the muscles. There is, actually, let me start this way. When his legs are crossed, at this position, you have the most compromise of the joint integrity. A sharp motion down the shaft of the femur will cause the head of the femur to puncture out of the acetabulum, which is why later we'll see from this position, to move him, we can dislocate the hip or subluxate it and then begin to move before continuing on with whatever little juicy tidbits we do to his legs. But on with the